Uh, Hey everyone, I am Harshishan Pathak, BTech student at NIT Hamirpur, and today we will be discussing about nanomaterials. As the title suggests, exploring the unseen, the realm of nanomaterials. So, firstly, we will discuss what we will be covering in the presentation. So, firstly, we will go through introduction of nanomaterials. This will include what a nanomaterials is, and then we will see unique properties of nanomaterials. Then we will go through types of nanomaterials. Then we will discuss about applications of nanomaterials in various fields, medicine, electronics, energy sector. And then we will do a short discussion about what is the future of nanomaterials. So upcoming slide. Introduction to nanomaterials. Nanomaterials are materials with structures at nanoscale. I hope all of you are familiar with a nanoscale. Nanoscale is 1 nanometer is equals to 10 to the power minus 9 meter. So nanoparticles or nanomaterials are something with structures at nanoscale, typically lying between 1 nanometer to 100 nanometer. So particles with structures which has size between 1 nanometers to 100 nanometers are characterized as nanomaterial. And these tiny structures exhibit unique properties that differ significantly from their bulk counterparts. This is something that makes them special because if you look at a carbon at bulk scale, what we can see from our naked eyes, its property are totally different from the properties we see in their nano material size. This slide is also about what are nanomaterials. It has the same thing as the previous. They can be classified into various categories such as nanoparticles, nanotubes, or nanoplates. And this is something that we should look on. That there is plenty of room at the bottom. Sir Richard Feynman, 1960. So I hope all of you or most of you are aware who was Richard Feynman. He was a great physicist, a teacher, and a scientist. So in a talk given at American Physical Society, he emphasized the idea of nanomaterials. He predicted that this branch of science has various application in the upcoming future. I have a quote from his lecture. What I want to say is the problem of manipulating and controlling things on a small scale, on a smaller scale. So he talked about that we are doing things at a larger scale and we have to go inside the smaller scale as far as we can go. So in the next slide, this is for our reference that we can see with various. A water molecule is zero point 0.1 nanometer small. Then a glucose molecule is 1 nanometer small size. An antibody is 10 nanometer. A virus is 100 nanometer. So this is the range where nano devices fall. Quantum dots and nanoshells and nanotubes. A tennis ball is much larger than a nanometer. It is 10 to the power minus 10 to the power 8 times larger than a nanoparticle. So you can imagine how small a nanoparticle is. Coming to the unique properties of nanomaterials, I have listed some of them here. What makes them special? Firstly, coming to the physical property, we can say that nanoparticles have high strength, they weigh very less, and you can take the example of graphene. We will see how graphene is made or what is a graphene in the next slide. And then in the chemical properties, we can say they have high reactivity due to large surface area. Uh, and in optical properties, we can say quantum dots glow in specific colors. Quantum dots are used in solar cells also. So it finds its application in various fields. And fourth is surface to volume ratio increases. We will talk about this also in the next slides. So firstly, let me just view here. So in the physical properties, we can say nanomaterials like graphene are extremely strong, 200 times stronger than steel by weight. Here, we can say what is a graphene? Graphene, we have seen the structure of graphite, layers by layers, layers by layers. You just point out one layer of graphite, and then you will get graphene. This the figure you can say structure of graphene says it all. And carbon nanotubes are lightweight, yet they have exceptional tensile strength. And carbon nanotube, when you wrap up a graphene, then you get a carbon nanotube. So these are structures which have immense physical properties, and they have immense strength and durability. Thermal properties, we can say high thermal conductivity. Graphene and nanodiamonds are such materials which have high thermal conductivity. And nanoscale allows integration into lightweight composites. So in electronics, we search for materials which are lightweight and useful also. So nanoparticles suit the best, serves the best particle for that purpose. And then we move on to chemical properties. In the chemical properties section, most importance is high surface area to volume ratio. There is an approach called bottom to top approach and top to bottom approach. There's two types of approaches. So in bottom to top approach, we try to build material from the smallest piece possible. And top to bottom, we build first largest and then go on. So what I am trying to say is when you are disintegrating the particle into smaller pieces, the surface area is increasing. You can see a picture of cube here. When a cube is whole, its surface area is 6 meters square. But when we divide it into 8 parts, the surface area almost doubled. Then we divide it into more parts, the surface area also doubled. So this same case applies to the case of nanoparticles. They are so small, hence their surface area is very large. So their reactivity, their catalytic properties are very large. Example you can see is titanium dioxide nanoparticles in sunscreen scatter UV light more effectively because they have large surface area. So due to large surface area, they scatter UV light more effectively and saves our skin from UV emission. And gold catalysis का example हम देख सकते हैं. Gold nanoparticle can catalyze chemical reactions at room temperature unlike bulk gold. So due to the large surface area, they can catalyze chemical reactions at room temperature. Unlike gold cannot do that, but nanoparticles can do. Then optical properties is what we can say quantum dots. This is very important in semiconductor physics. Semiconductor nanoparticles that emit different colors of light depending upon their size are called quantum dots. These quantum dots finds application in various things that you can see in displays, in solar cells, in imaging. So this is very useful. They use the optical property of nanomaterials. The image is also attached here. It shows how gold changes their color depending upon their size. The gold nanoparticle shows different color at different sizes. So now we came to the types of how many types of nanomaterials we see in our surrounding. So based on the material used, we can say they are carbon based, fullerenes, graphene, nanotubes. These are all made from carbon, so they can be classified under carbon based nanomaterials. Then metal based, silver, gold, titanium oxide nanoparticles. Then there's something called dendrimers. They are nanoparticles of polymers. So they are named as dendrimers. And then there's something called composites. These are hybrid materials which are made from different type of materials. And this is something we learned in our lecture also. Types based on dimensionality. Dimensionality is a dimension we all know that height, length, breadth, three dimension. Then if a particle is on a planar surface, it doesn't have height, so it is 2D. Or if a particle only have a length, so it is 1D. And when we talk about quantum dots, it is 0D. It has no dimension. We talked about in the optical properties of nanomaterials. So, zero D nanoparticles are confined in all dimensions, such as quantum dots. Then nanotubes, they extend in one dimension only. They have only length. So they are 1D nanomaterials. The nanosheets, nanoplates or graphene plate, you can say they are 2D nanomaterials. And then 3D nanocomposites, nanoscale feature throughout three dimension. There's also a image attached. You can take the reference from that. And then we move on to application part. Application in the medicinal field. So nanomaterials are transforming medicinal field through applications like targeted drug delivery, imaging, bioimaging. We see that quantum dots can be used in bioimaging and diagnostics. Their ability to interact at a cellular level enable precise treatment and reducing side effects and improving the patient's outcome. In the previous section, we talked about how their properties help them to be a better catalytic agent or to be to increase the reactivity of reactions. So these properties help nanomaterial to find a wide range of application in the medicinal field as listed here. So next slide. In the electronics, we also talked about quantum dots. They have a wide range of application: solar cell, LEDs, lasers, photo detector devices, photocatalysis, single electron transistors, and TVs and displays. These are all areas where they can be quantum dots can be used. Innovations such as quantum dots and graphene are revolutionizing components like transistor, sensors, and displays because they are very small, they are very lightweight, and they could do the job in much efficient way. So they are very much demanded in semiconductor or in the field of electronics. Then we have nanomaterials in energy. Nanomaterials are playing a pivotal role in the energy sector by enhancing the efficiency of solar cells, batteries, and fuel cells. Fuel cells is something we know we have learned. Their quick, their unique properties enable better energy storage and conversion, driving the transition to sustainable energy. So, in the coming era, we are seeing climate changes and many environmental changes affecting our surroundings. So in this era, nanomaterials can pave a way to a sustainable energy source. There are various materials such as quantum dots, graphene, nanotubes, fullerenes. We have seen environmental impacts such as nanomaterial holds the potential for sustainable solution to environmental challenges. They can be used in water purification, air filtration, and energy storage, contributing to a cleaner and more efficient planet. So, in the upcoming future, nanomaterials has a bright future, and with ongoing research leading to innovations in applications in fields like energy, biotechnology, and material science. As the technology advances, we can expect even more groundbreaking discoveries. In the conclusion, I would say that there are very possibilities. There are research going on. There are researches going on, and the world of nanomaterials is a realm of possibilities. As we go on, we can see many changes happening in our surrounding and many things related to nanomaterials. So, thank you everyone for watching this. Again, I am Bhushan Pathak from NIT in Hamirpur. This is my roll number. Okay, thank you.